Welcome to the Potato Podcast. We keep it chill, raw, and a little fried. Just like a good potato. Sometimes deep, sometimes totally random. No filters, no fake vibes. Just real talk, weird thoughts, and good energy. Let's get into it.
Welcome to the deep dive. So if you get a chance, maybe tonight, look up at the night sky. Try to get away from the city lights if you can.
Yeah.
And just think about possibility of exploring all that vastness out there, discovering things we can only really dream about right now. And the idea that humanity doesn't have to be stuck here, on this one little planet.
Exactly. And right at the center of making that possibility feel maybe a bit more real, there's this one machine, Starship.
And we've been looking closely at some excerpts from a source called The Promise of Starship, Reaching for the Stars.
Right. And our aim today isn't just to describe the rocket. We really want to unpack what the source material is saying about it. Because it presents Starship as, it's hardware, sure, but it's also this potential economic shift.
Okay.
And maybe even a philosophical statement about where we're headed. Plus, this very public, real-time experiment in building something huge.
That framing, that immediately makes you think differently. It's not just a big rocket. It's all those ideas kind of wrapped up in stainless steel.
Pretty much.
So, okay, let's dig into the source material then. Just physically, what is Starship? Like the basics.
Okay, so the source describes it as a two-stage system. Super heavy lift launch system built by SpaceX, obviously.
2 stages.
Yeah. You got the super heavy booster. That's the first stage, the bottom part. Its job is basically brute force, just getting this massive thing off the ground through the thickest air.
Right. The heavy lifting part. Makes sense.
And then sitting on top, that's the Starship spacecraft itself, stage 2. And that's the bit designed for, everything else. Space travel, moving around up there, and landing, which is key.
And the source makes it really clear this isn't just about landing back here on Earth, right? It's designed to land on, say, the moon, maybe Mars eventually.
Right? Mars, yeah.
And then be ready to launch again from there.
Exactly. And that leads us straight into, I think, the first really huge point the source emphasizes. The entire system, both stages, is designed to be fully and rapidly reusable.
Fully and rapidly. Those are the key words.
Definitely. We're not talking about just fishing a booster out of the ocean like they do with Falcon 9 or, needing months of work to get it ready again. The vision here, the promise in the source's title, it's much closer to how we think about airplanes.
Okay.
You land it, you refuel it, you check it over, and it flies again. Maybe even the same day, eventually. It's a total break from how rockets have always worked.
Yeah.
Traditionally, they're throwaway machines, mostly.
Yeah, just incredible. And you really get a sense of that ambition when you look at the sheer size of this thing. The source mentions when it's fully stacked, Starship and super heavy, it's about 120 meters tall.
Roughly, yeah. Close to 400 feet.
That's taller than the Saturn V rocket that took us to the moon.
It is. Tallest rocket ever built. It's genuinely massive.
And that size isn't just for looks, obviously. The source talks about payload capacity. What can it actually carry?
Well, the design goal is over 100 metric tons to low Earth orbit.
100 tons?
Yeah. Which, rivals or beats pretty much anything that's ever flown before. To put that in perspective, that's like lifting, I don't know, maybe 22 big elephants worth of weight into orbit in one go.
Wow. Okay. Elephants to orbit. Got it.
Yeah, something like that.
And there's this detail the source brings up that always surprises me a bit, the material. The spacecraft itself, the top part, about 50 meters long, it's mostly stainless steel.
Yeah. It seems odd, right? You'd think it would be all fancy composites.
Exactly.
But the source explains it's a strategic choice. They weighed up things like cost, obviously, but also resistance to really high temperatures during re-entry through the atmosphere and just basic structural strength. Steel ticked the boxes surprisingly well.
Okay. And powering this beast, what kind of engines are we talking about?
They're SpaceX's own Raptor engines. The source describes them as next generation, full-flow staged combustion engines, which is a very efficient but complex design. And they burn liquid methane and liquid oxygen. Methalox, they call it.
Methalox. And that fuel choice, that's not just random either, is it? The source connects this to the bigger picture.
Not at all. It's absolutely strategic. Tied directly to the Mars vision. The key thing is you can theoretically make methane on Mars.
Right, using resources that are actually there.
Exactly, using water ice, which we know is there, and carbon dioxide from the Martian atmosphere. It's this concept called ISRU, in situ resource utilization.
ISRU.
So the idea is Starship could fly to Mars and then refuel itself using Martian resources for the trip back, or maybe even trips to other places from Mars.
That just changes the whole equation. You don't have to haul all the return fuel all the way from Earth.
It's potentially revolutionary for deep space logistics, a total game changer if they can make it work reliably.
Which leads us, I guess, to the next major theme the source really digs into: how Starship is meant to completely change the economics of getting to space.
Yeah, this is huge. This is where that reusability and the sheer scale really come together.
The vision described in the source, it's about making space travel not just possible, but frequent, fast, and maybe most importantly, affordable, or at least dramatically less expensive.
Dramatically. The source talks about the potential cost per kilogram to orbit. Traditionally, that's been maybe tens of thousands of dollars per kilo with expendable rockets.
Astronomical costs, literally.
Right. But the source suggests that if Starship meets its design goals, full reusability, high flight rate, that cost could potentially plummet, maybe even down to under $100 per kilogram eventually.
Under $100. Just pause and think about that. What does that kind of cost reduction unlock for you, for humanity? Maybe not booking your personal trip next year, but think bigger.
Right. Suddenly, deploying massive constellations of satellites for global internet.
Yeah.
That becomes much more feasible, almost routine.
Building large space telescopes, way bigger than Hubble or Webb, much cheaper.
Setting up actual infrastructure on the moon habitats, power stations. That moves from sci-fi towards engineering possibility.
Space tourism could become accessible to more than just billionaires.
And then there's the really big one, the long-term goal the source highlights. Making the colonization of other worlds, like Mars, actually seem plausible. Economically viable, even.
So what missions does the source say Starship is actually designed for? Let's start near term.
Okay, near term, it's already a critical part of NASA's Artemis program, the plan to get humans back to the moon.
Right, the source specifically mentions SpaceX won the contract to develop a version of Starship as the HLS, the Human Landing System.
That's it. So this could be the actual vehicle that takes astronauts from lunar orbit down to the moon's surface for the first time in, over 50 years?
Wow, that's a huge near-term goal right there.
Absolutely. The source really emphasizes that connection to Artemis. But the long-term vision, the one Elon Musk talks about constantly, and the source details, that's much, much bigger.
Which is?
Making humanity multiplanetary, spreading life beyond Earth.
And specifically, the source mentions Mars.
Mars is the focus, yes.
Yeah.
The goal isn't just to visit, it's to build a large fleet of starships. Hundreds, maybe thousands eventually.
A fleet?
Yeah, capable of making regular flights to Mars, carrying lots of people and cargo relatively cheaply. The ambition stated in the source is just staggering, talking about potentially sending 1 million people over several decades.
1 million people.
To build a self-sustaining city, a civilization on Mars. It's an incredible goal.
Okay. Attempting something that, frankly, sounds like science fiction requires a pretty unique way of doing things. How does the source describe the development process for Starship?
Well, it highlights how incredibly iterative it is and how public.
Yeah, if you follow space news even casually, you've seen it. All those tests down at Starbase, their facility in Boca Chica, Texas, you see the prototypes being built out in the open.
Exactly. We saw Starhopper doing its little hops. Then the SN series, SN8's flip maneuver.
Yeah.
All those tests. Booster tests, B4, B7.
Many ending in spectacular fashion early on.
Right. And the source describes this approach as really aggressive. A fail-fast mentality. Build it quickly, fly it, see what breaks, learn from it super fast, and build the next one.
So those explosions weren't necessarily failures in the grand scheme.
Not entirely. The source argues that even the tests that ended badly provided absolutely crucial data. Data on materials, on engine performance, on aerodynamics, on manufacturing techniques. They learned so much so quickly precisely because they pushed things to the limit and weren't afraid to see hardware destroyed.
And we've seen that translate into progress with the big full-stack orbital test flights they started in 2023 and 2024.
Yeah. And while, they haven't achieved all their objectives on those flights yet,
Not yet, no.
the source points out the incredible steps forward, getting that massive stack off the ground, achieving successful stage separation between the booster and the ship, controlling the vehicles during parts of atmospheric reentry.
And just the speed they're turning things around, fixing issues, building the next vehicles, getting ready for the next flight attempt. The iteration speed itself is remarkable.
It really is. And the engineering challenges they're tackling, especially around reuse, are immense. Landing these huge rocket stages back on Earth or elsewhere, it's incredibly hard.
Especially the Starship landing, right? The source talks about that unique maneuver.
Oh yeah, the belly flop. It's one of the most visually striking and technically complex parts.
Yeah.
The idea is the Starship comes back through the atmosphere broadside on, using its body and those big fins or flaps for control, kind of like a skydiver.
To slow down using atmospheric drag.
Exactly. Maximize drag, bleed off speed.
Wow.
Then, right at the last moment, it flips itself vertical using the Raptor engines and performs a final propulsive burn to land softly.
The source really paints that as breathtakingly complex, but absolutely necessary for the whole reuse concept.
It is, because the goal isn't just to land it, it's to land it gently enough and intact enough that you don't need months of repairs.
Minimal refurbishment. That's the key phrase the source uses.
Right, so you can turn it around quickly, maybe fly multiple times a day eventually, just like an airliner.
Yep.
That's the operational model they're aiming for, according to the source.
But, aiming for something this huge, this transformative, becoming multiplanetary, it's not just an engineering problem, is it? The source touches on the philosophical side, too.
It does. It frames Starship as more than just metal and engines. It's a symbol.
A symbol of what?
Human aspiration, maybe. A statement that we're not going to just stay here forever, that we intend to reach out.
Okay. Yeah, I can see that.
It kind of embodies this belief, this maybe audacious belief, that the challenges of space, the vacuum, the radiation, the distance, they aren't insurmountable barriers. They're just really hard problems that we can solve.
With enough technology, enough willpower.
Enough imagination, yeah. The source even brings in that quote from Musk about wanting people to wake up and be excited about the future. And Starship is presented as his kind of tangible answer to that feeling.
It really does feel like this blend of, old school science fiction dreams and very real, very difficult, cutting edge engineering.
That's a good way to put it. But the source is balanced.
Yeah.
It doesn't just present the dream, it also acknowledges the criticisms and concerns.
Right. And we should touch on those too, neutrally, like the source does. It's not all smooth sailing or universal applause.
Definitely not. There are significant environmental concerns raised, especially about the Starbase launch site being near ecologically sensitive areas down there in Boca Chica. Launching rockets that big has an impact.
That's a big one. What else?
Well, the whole Mars colonization dream itself gets scrutinized. The source mentions critiques, questioning if it's even technologically realistic on the kind of timelines Musk talks about, or if it's ethically, complicated.
Complicated how?
Things like, who gets to go? If it costs a fortune, is it just another escape route for the rich? Who governs a Mars colony? What are the rules? Do we risk repeating Earth's mistakes out there?
Those are really thorny questions.
And the source also reminds us about the very real dangers to the astronauts themselves. Deep space radiation is a huge issue outside Earth's magnetic field. The long-term effects of Martian gravity, which is only about 38% of Earth's.
And just the psychology of being isolated for months or years so far from home?
Exactly. Mental health challenges. These are all presented in the source not necessarily as deal breakers, but as absolutely critical issues that we as a species need to think about very carefully before embarking on something like this.
Okay. So acknowledging those challenges, those criticisms. Let's swing back to the potential upside. If Starship does work as intended, if it delivers on that promise the source outlines, what's the payoff?
Well, the potential impact is just enormous across so many fields.
Like what?
It could completely change space science, letting us launch vastly larger telescopes or complex probes much more cheaply. Telecommunications, with those mega constellations we talked about, providing internet everywhere.
Yeah.
Maybe even asteroid mining or orbital manufacturing become economically viable.
The source even mentioned things like building the first real lunar base, not just flags and footprints, or maybe even using Starship for super fast cargo delivery between points on Earth, like hypersonic travel.
That point-to-point Earth transport idea is floated, yeah. And things like delivering components for space hotels or large orbital stations. It's really presented as less of a single-purpose vehicle and more of a foundational platform.
A gateway.
A gateway, exactly, to a whole new era of human activity in space, where the main barriers, cost and scale, have been drastically lowered.
So, wrapping up how the source material seems to portray Starship, it's really not just one thing, is it?
No, it comes across as multifaceted. It's definitely a technological moonshot pushing the absolute limits of engineering.
It's potentially a massive economic disruptor for the entire space industry and maybe beyond.
And it's also this kind of philosophical statement, a challenge about humanity's place in the cosmos and our future.
It really forces us to ask, can space be opened up to everyone, not just a select few government astronauts or billionaires?
Yeah.
Can we actually bridge the gap between Earth and, say, Mars?
And the source makes a compelling point that whether Starship achieves all its ultimate goals or not, or how long it takes, it has already fundamentally changed the conversation.
How so?
It's just made people think bigger about what might be possible in space. It's shifted the Overton window, you could say, for space exploration and development. It put Mars on the table in a way it wasn't before.
So the next time you're looking up at that night sky, just take a second. Remember that right now, somewhere down here, teams are building this thing, this Starship, designed ultimately to reach for those stars you're looking at.
It is a pretty powerful image when you think about it like that.
Yeah. And maybe that leaves us with a final thought for you, the listener, to chew on based on all this.
Yeah.
If, and it's still a big if, but if the technical hurdles get cleared and the economics work out and large-scale Mars colonization actually becomes a real possibility within, say, our lifetimes, what does that really mean for us as a species? What kind of ethical, social, maybe even existential questions does that kind of future force us all to confront about who we are and where we're going?
It's definitely a future that would be incredibly complex, full of challenges, but also undeniably profound potential.
Something to think about. Keep exploring those ideas. Thanks for joining us for this deep dive.